you have to approach this from the perspective of an agent. And that's where the empath part comes from. The factory, that's what I've been hearing it called, harness engineering, yada, yada. I do think that the factory-like model will be the process in the future. That's what I'm seeing already from my team and from other teams as well. And for the most part, everyone has, it's funny, right? A lot of people have gone to the same spot that have never met each other or that have not spoken. Like even myself, when I'm on X, I talk to people like, oh, we both arrive at the same conclusion and we didn't discuss it. So I think this pattern will be repeating in the industry. But that's more of a aside. Anyways, okay, so jumping in. Agentic factory coding from first principles as an empath. And again, AI kind of slopped me, but bear with me. So the core workflow, there's a lot of this, and I spent like a year teaching a bunch of people this type of things, and it took a while for it to click through. But once you do click it, once it does make sense to you, you'll be able to spin up a lot of stuff, and you will be able to like easily operate. Like I usually always have at least 3 code agents going. I have one that's constantly doing research, one that is constantly cleaning stuff up, and then like my main workflow that's in the middle. But at first, it was a bit of a weird mental state to get into because I usually would just have my editor open and just one terminal. But now I can easily like just jump between tabs and it doesn't mess me up. But it does take a bit. But the core of it is this: it's the research, planning, and the actual execution. And we'll go over this in more detail. But this is the core of it. Here are my actual notes. So if we do, it's bigger. Okay, so the phase 1 of this is the research. This is one of the most important parts of the process, and the process that you should probably be spending the most time on. Research. This is usually going to mean deploying subagents to map out stuff, and that's one of the biggest benefits: the ability to quickly, iteratively deploy an agent and say, "Hey, map out. How does the off module work?" Right? Back in the day, like the first thing you would do when you would hit a project that was of enterprise size, you would always reach for the documentation, and if you were lucky, you had documentation. But even if you had documentation, it was probably outdated. It was probably a mess, right? Nobody had taken the time to handle it. So usually I was just exploring myself with grep, with all these tools to map stuff out. Now that's been pretty much all replaced by the subagents. The subagents can very quickly, and again, the key here is like it can quickly do it and iteratively. It can just go, go, go. And I might do it 2-3 times until I really understand what is happening. And the agent is mostly doing what you would do regularly, right? It's globbing, it's grepping, it's reading. The difference is it can do it in minutes, whereas it would take you much longer. On top of that, the research also usually involves web searching. So for example, if I'm using a new library, if I'm using a technology that I'm not as familiar with it, I will have it either Google, or I'll just straight up give it the link to the documentation and say, hey, go read this. We were talking about MCPs. So I'm not a fan of MCPs mostly, but I do use 2. I use the EXA web search, and they also have an EXA code search, which will try to find the most updated documentation on popular libraries. So for example, you're probably using React, right? It will go and grab all the latest React documentation. And Context 7, they do a similar thing, but they both really build off the web research. That's pretty much what they're doing. These are just kind of dedicated tools that I've used quite a bit, and they are the most effective ones that I've used. There's a bunch of these, and you could probably just do it with just EXA itself, but these 2 tools have been effective for me. So all of this to say, you still need to really manually review it. This is one of the biggest issues that I've had, both at work and just in general. A lot of people, once they finally do get this clicked and once they do lock in, it's like, okay, they start to treat the agent as concrete, and none of this will work if this phase is fucked up. Like your entire next phase is gonna be fucked up. The next one will be fucked up, and then you don't want to let this slide through because it'll just keep building on top of each other. And it's very easy to slopify code base. Like you can pretty much destroy a code base within a week if you allow it to, because the code agents let you move so fast. So all of this to say you have to review this manually or I will kill you, because this is the foundation of your entire workflow. So research, you get the idea. Yeah, this is terrible. But yeah, I'll show an actual example. So so I don't use Claude anymore, but I will still use Claude Code, and I'll show another one as well. So I have a research workflow that I use now, and it's let's see, yeah. So it's a command. These are becoming kind of the same thing. Back in the day, the code agents could not reliably go and say, "Hey, I want you to do X." So Claude Code made a feature where it was a slash command. You could say slash, it would inject a prompt, and then you would feed it whatever you wanted to do. So this is what I was doing originally. I'll show what I'm doing now, mostly on the other side. But I'll say something like map out the, let's say, system prompt. And the skill, the action, you could, if you're using even like something like Codex 5.2 high, you'd probably just straight up ask it to do this. But this is the one that I'm most comfortable with. I'm able to say, hey, here's my question, query, whatever you want to call it. It's going to spin up 3 subagents. So locator, analyzer, and synthesis. And I'm just strictly interested in what it finds. I don't care about possible solutions. I don't care about this looks off. Like its sole role of this phase is to do this research. And I also have a skill that I use a lot now. So let's say something like use the code base research skill and map out the agent configs. Now this is GLM 5. It's pretty good from my testing, but it might not always use it. Okay, yeah, so you can see here on open code, on most code agents, Claude Code as well, it will tell you like, hey, we've loaded up this skill to let you know that it's being used. And the research skill, it's pretty much the same thing, just a little bit tweaked. So you can see here it's spinning up 3 subagents. You can see that they're already like trying to glob and grep. So they're mapping stuff out just like you would as a normal human with like rip grep or whatever CLI tools you would use. It's doing that, but it's doing it all autonomous for you without any input. And this is the key right here, like just mapping stuff out. And once it finishes, it's going to show me a report and we'll go over it. And it's your job to make sure wherever it got generated is correct. If something looks off, something feels weird, don't ignore that feeling, because it's most likely your experience coming through and saying, hey, this looks off. Or maybe you're wrong, right? Maybe you swear to God that you added that module, but for the reason it wasn't there. It's very important. I cannot stress how important this is. So this is what generally all the reports look like. So the font matter. So these are enforced with this same template. So everyone follows the same template. That makes it easier to read for everyone else. But also this can end up becoming context for yourself, right? If you were saying like, hey, all of a sudden the auth module has broken, you can go back and say, hey, what exactly did we do? You can start mapping some of these documents out. But it's just basic font matter here. And the goal here is to map the system prompt architecture in Tunicode, where it lives, how it's constructed, what it includes, yada, yada. And it can log the actions that it took, right? So for example, it tried to grep in the Claude directory and the source directory. It only found it in the agent config, canonical, and adapters. And then the overall system prompt, this is exactly where it lives. And I know for a fact this is correct because I've been obviously working on this code base, but found the system prompt. It found how it constructs it. It found how it loads it, how it integrates with the tools, how it gets cached, the types. All this stuff was mapped out 100%, right? So imagine, it's your first day at Tuna Industries. I say, hey, I need you to map out how the system prompt architecture works. Back in the day, you were just doing Control F or grep, hopefully. And this would take you, sometimes it would take you a day, depending on the size of the code base. Like imagine an enterprise code base that's like 500,000 lines. This would have taken you a day, maybe even half a day. But now it's done in minutes. So for the most part, I can usually trust this, especially if you're using a good model, meaning Codex, Claude, Gemini, Kimi K2.5, and GLM5 have been pretty good for my testing. So as long as you're not using a really small model, if you are using a small model, you'll probably use one that's fine-tuned for coding. For the most part, this is usually accurate, but I still review it, right? I don't want any misunderstandings. If anything looks weird, anything looks off, I'm just gonna nuke this. I'm not even gonna look at it anymore. I want to make sure that when I pass the research prompt, I say, hey, don't worry about X. Don't even look at it. Let's do this thing instead. Any questions, comments, or concerns? All right, I'll take that as a no. Yeah, the memory bank, all it is a, I'll show you. So it's just a directory with the plannings, right? So all the plans that I have are here. And this is mostly either for yourself or for your team. This way you can kind of, some people don't track this. I think, anything can be context. It can definitely get a bit overwhelming, right? If you have a bunch of people sharing their memory banks and it's being tracked by Git. But it's worth it to keep it at least, even if you're just keeping it locally, because you could easily look back. And for example, let's say you have a research phase, you do whatever for the off module. Then a week later, right, the off module starts acting up. Well, it's like, wait, what did we do? Okay, I see this research phase. I see this plan phase. Okay, I see this execute. Here's what they did. Now you can still do it with Git. You can still do it with other tools, but it just gives you a little bit more context when you have a similar issue or when you have something that's like adjacent to it. You can easily go back, and because it's formatted, you can easily go back and say, hey, like where is that? Okay, I see that ticket here. Boom. But that's all it is. It's just like a little directory for your documents. So GLM5 did not make the document, or no, it did. Retarded. Yeah, never mind. Sometimes the agents, again, if you're not using Claude or Codex, they're not going to always follow your prompt. For the most part, Claude and Codex tend to do a very good job of that. But that was it. Once you fire that off, now you have an idea of what you're working with. If I go to one terminal to make this a little bit focused. Okay, so I have my research. Now I'm going to go into my planning. And I'm going to say something like read system, even without tagging it, because it loads up the prompt, it should be able to find it, even if it's a older GLM model. For the most part, because the way the command is structured, it should be able to go and tell what I'm talking about. So I'm not even going to point at it. It should, look at the, let's see. Yes, so I found it. I'm going to say something like, let's add prompt versioning, right? So I've done my research, right? I took the time because I'm not stupid to make sure it's correct. If I'm unfamiliar with the library, if I'm unfamiliar with the technology, I'm going to throw in some web research. But again, this all hinges on on your manual review, right? If you have any questions, anything that you're unsure of, it's worth iterating this process at least a couple of times to make sure that your research is correct, and that you really can't get around it other than manual review, in my opinion. Once you finish this, so your research document is done, right? Like you've done all that. The next phase is going to be planning. So a couple of things. You should probably want to iterate this. It still needs to be reviewed manually, especially at this point. But a couple of things to note. You want to have all this stuff done ahead of time for the next phase. So you want to make sure that you're in you have a clean Git. It's very important that you outline the scope and that you outline the scope for what you're not doing. Code agents tend to be very trigger happy depending on the model. So you have to clearly outline the scope. You have to clearly outline what not to touch. If you leave it to chance or you don't clearly say, hey, don't touch the tool module, right? We're just working with the prompt. Don't touch anything else. Depending on the model, it will try to quote unquote fix it, or maybe it'll just move it just because whatever reason. Just outline it cleanly. Hey, we're not touching this. You want to make sure like all your tests, all your linting, all that's done ahead of time. You don't want to start feeding the context window some stuff that like this could probably easily take up like 20K tokens. So you don't want to feed this before. You want to have all this stuff ready to go, done, clearly outlined. Once you have the research document, it's up to you now to set up I would say it goes like the overall goal, right? So for this, we're trying to add versioning to a prompt. That's a goal. It's going to generate the milestones, and it's also going to generate tasks. This is interchangeable, obviously, if you're using Agile, if you're using whatever type of task management at your environment or team. But the overall arching concept is the same: goal, milestone, task. The question you want to ask yourself when you have a research document is, if I handed this to a junior, can they know for sure what to do? You don't want to leave vagueness. You don't want to leave room for interpretation. You need to clearly outline this for the code agent to say, do X. Here's how we're going to do it. Here's the milestones. Here's the task, etc. So let's see if it finished. So the goal here, add explicit version tracking for the system prompt and tool prompt changes in tuner code. The rest of this is kind of fluff. So whenever you're going through it, this will serve as context for your execution phase. So it's not worth keeping here, right? When I feed this to my context for execution, I don't need to fill all the extra fluff of this stuff. This is mostly just to make sure as a demo that everything is right. So you can see here the scope, right? We're doing version tracking for the prompt of the system and the tools. Out of scope, right? So don't touch the UI. Don't touch anything with the storage or syncing, anything with the automated prompting, the multi-model prompt variants. We're not doing that whatsoever. I'm just going to straight up delete it. So here's the assumptions, right? Version, metadata stored locally. I don't know what that is. Yeah, so for the most part, like this is just saying like, hey, I'm assuming you're doing X. That's going to lean towards the median of coding in general. So if you have any assumptions that you are not sure of or not 100% positive, it's worth going back and iterating to make sure that this is correct. Deliverables, so just what we were talking about, right? What you're actually going to be giving me when you're done. Preconditions, so this is what I went over with the ready to execute. It's very important that you do all this ahead of time. You don't want to feed your execution agent any of that context that's not going to work for you. And it's just going to take up extra context. So it's going to give me a data schema. So you see here the milestones, the core versioning, data structure. We have 1, 2, 3. We have 5 milestones, and then it breaks down the task into individual granular either diffs or new files. And it has relationships between the milestones. The estimate, Claude loves giving estimates. I should probably delete that. It's not going to hurt, but that's not worth mentioning. So risk mitigations. So potentially what does this touch? If you're working on an enterprise code base and it has like 1 million lines of code, 500,000 lines of code, obviously it's very important that ideally, your code base is nice and clean. It's modular. It's professional. but obviously that's not always the case, right? You want to make sure that you're aware, or that Claude's aware, whatever model you're using, that we're touching this auth module. The auth module is very tightly coupled with, I don't know, the database account module, right? Stuff like that. You just want to outline that ahead of time for Claude in case anything happens. It can be guided. It can not freak out whenever something happens. Testing. So this is more preference testing strategy. I make it outline what kind of tests we're going to be doing. I really just don't like how most code agents do test agents or tests in general. They tend to do a bunch of tests. They tend to do a bunch of tests that just kind of want to pass. But that's what people do, right? So that's why it's doing it that way. I really just like to see one test per feature, and I like to see negative boundary testing to make sure that it actually works. A lot of times you'll run into an issue where the code agent said they made a test, and the test passed, but the test is terrible. It's ass, and it's like it doesn't matter if it's just testing nonsense. That doesn't help me. So I like to make it simple, and I like to have negative boundaries. And then lastly, just the summary. Nothing too exciting there. Any questions, comments, or concerns? Right.
Just one comment. You're so handsome.
Thank you. Anyway, so we have wait, what is bozo? Two bozos in here? That's crazy. Um, so once you have your once you have your plan, now comes the phase of the execution. Now, if you've done what you're supposed to do and you've taken your time, you have made sure that your research makes sense. You've made sure that your planning makes sense. For the most part, this is hands off for me because I've done all the work ahead of time. I've done all the mapping. I've done all the preparation. All that is pretty much done, and I am ready to go. So if you do what you're supposed to do, you follow best practices, etc. For the most part, execution is ready to go. So, perfect example, right? I'm gonna master here just as a demo, but you get the idea. So I'm gonna just quickly commit. Okay. So before I commit, I'm running my Git. My Git is clean. Um, activate my virtual environment. I'm gonna run my test just to make sure, right? Uh, so because the code agents allow you to generate a tremendous amount of code very quickly, you can easily start to get a lot of slop. You can easily start to, one of the issues that we had when this first got introduced into the team is that a lot of people were going very fast. They were, branching off master. Maybe they would need to rebase later, yada, yada. Pretty much now the procedure is like, hey, once you clone master or branch off master, main, whatever, it's your responsibility to make sure that everything quality gates wise is passing. Now it should, the actions, the CI, CD should catch all that. But again, especially if you're new to this, it will go a million miles an hour and it's very easy to let stuff slip through accidentally. So just, hey, you're good to go. There's no issues. Boom, execution. And for the most part, that's usually 100% hands off. Okay. So this is your plan document. I sometimes I use this tool called Tickets. It's a CLI tool that helps you. Basically, it's like a to do. There's also a task master MCP that's really popular. I used to like to use this on the older Claude models because they tend to reward hack a lot. For the most part, I don't use it anymore, but I know it's still used and it's still popular. And you can also just straight up say, hey, release this track if you get. That's perfectly reasonable. There's a bunch of other tools that you can use. I know there's beads that is pretty popular. And I imagine there's more, but basically you can add little granular tasks. For the most part, I tend to keep it either as a spec document or as a Git issue, but this is just extra. The important part here is your document. Like I mentioned, executions are pretty much hands-off 100%. So let's start this. Okay, so it has full permissions. Now I bypass permissions. I'm not retarded. I use Git, so I don't have to worry about this blowing up my environment. If you really want to be, a paranoid, you can have a Docker container, a sandbox environment. That's very popular now. I really don't see the point for my use cases, mostly because we tend to work with our own infrastructure, and I usually have backups upon backups, so I'm not really concerned. And I'm sure there's been examples of it. I really haven't had a code agent go rogue on me. Maybe it'll happen one day and I'll learn my lesson. But for the most part, I just give it all the permissions, let it rip. I don't care. The whole point of this is to let it run autonomously. And if I have to babysit every single little edit, it kind of defeats the purpose, in my opinion. So it's going to make sure just really quickly that we're clean, and then it's going to start executing. Again, this really, you have to make sure that your phases 1 and 2 are granular, they're correct, there's no misunderstandings, you don't want to confuse a code agent. Again, the North Star is like, if you handed your plan to a junior, could they execute this 100% without having to read anything else? That's what you want. For myself, this is more of a flavor thing, but I have it commit between milestones. Between milestones, I have it run a script that is basically all the quality gates. So think like testing, linting, all the other hooks that I might have, for example, like dependency directions, architecture boundaries, making sure stuff is not trying to leak together, or if it all of a sudden it starts to, make its own utility function, completely bypassing my dependency directions, catch that. And I hide all the context from the agents. I just say, hey, basically just run the gates. And all I want to know is, are all my standards in line? Yes, no. If not, it's going to just show that one thing. And that way I don't overwhelm the model context window. I just say, hey, here's what's wrong. This was working before we started, fix it. And also, just as an aside, I have to write down any notes or issues that I might run into or that I found interesting. This is obviously very subjective, but for the most part, most models will tend to do a good job of taking notes. And you'll see that a lot once you start using this. Okay, so I'll let that finish. Probably don't have the time to do the code review, but it's also, all this is important, but of course the code review, that's like the final line of defense. Again, code agents let you move very fast, and if you give this to a junior, it's just like the monkey meme with the gun. Like, there's a lot of damage that can be done. Wait a minute, hold on. This is, no, okay, it's fucked up. 1 second. I meant to hand it the plan document. Okay, sorry about that. So this is going to be hands off, ask for permissions. The pull request and the code review, this is key. It's very easy to go very fast. If you let slop sit through even one time, you can destroy a code base within a week if you just add a bunch of slop. It's not just about linting and testing, but also just architecturally, right? The code agents love to solve the problem in a very localized way. Whereas if you know what you're doing, you should be solving that in the architecture way, right? You should be mapping out like, hey, here's our utilities, here's our types. Hey, here's how we handle X. You don't want to let the code agent do that because before you know it, you'll have a code base that everyone has written their own utility function. Everyone has written their own authentication functions, right? You want to avoid that. So it's very important that you read the diffs. I'm a big fan of the Delta. You can spin it up and have it, not spin up, it's just a CLI tool that lets you very easily see the diffs. Obviously, like you would in GitHub, I just prefer Delta as a preference, but the diffs have to be read. You have to make sure that there's no weird slop, no weird patterns. That's on you to enforce. You can also use something like CodeRabbit or some sort of agent that reviews your pull requests in general. Just a second set of eyes, make sure all looks good, make sure nothing looks off. You want to confirm, again, the speed that you're going to be able to go to is much faster. So it's very important, always was, but even more now. Your CI, CD stuff is going, your pre-commit hooks are firing, your tests are actually testing, because one PR of slop easily turns into 10, easily turns into 100, and your code base is destroyed. An interesting thing that I've done recently is once we run into a situation where we have a code review and the issue has popped up more than once, meaning, for example, the team had different rough versions, right? So that happened twice. I said, okay, we're going to add a skill. The skill will be used locally in this project. Hey, just make sure everyone's on the same environment, have a reference file, have a script, and all of a sudden that issue should not happen again, right? So as you are doing your code reviews, pull requests, that also serves as context, and that also serves as this like continual learning. Whereas if you see a mistake, you can literally just ask any code agent, hey, we had this issue for our test. This has happened multiple times now. This test is very flaky. What is wrong? What has gone wrong in the past? And how do we prevent it at the code level? This is very important because all these standards need to be enforced not only with skill, not only with yourself, documentation, etc. But because you have the ability to go very quickly, you need to make sure that you are enforcing all of your standards at the code level because you're not to be trusted. Stuff just slips by. People are human. They're going to forget. You have to make sure that gets enforced at the code level. That could mean a test for something as simple as your dependency directions. That could be a test. I've even seen tests for documentation. So if you have a very important module and it uses 4 functions, you want to say, hey, we have a test. Nobody add a function. Nobody remove function. If that fails, it'll fail because the documentation that we have, it's linked to it. And someone added a new function. There's no new mention of that in the documentation. Fail. I want it to fail because that is a standard that we need to enforce, that because of how fast the team can go now, like I don't want to let anything slip by and it has to be enforced at the code level. There's a bunch of little unique things you can do like that. For the most part, you just want to make sure that as problems arrive, you enforce the solution at the code level. So it's more of the same. So, reading the diffs, using something like CodeRabbit, again, enforcing all these standards, they have to be enforced at the code level. And you could probably just get away with it with an action or with pre-commit hooks. It's just worth bringing up because that's a problem that I've seen a lot. So this is from one of the resources that I just shared on the chat. Codex, OpenAI. You'll hear this term a lot, harness engineering. But they were able to show how they're pretty much working 100% with just code agents. There's really not any more manual stuff they're doing. But some things they noted that I found interesting, the agents.md. A lot of people tend to stuff their agents.md or your Claude MD with a bunch of stuff. And for the most part, most models will just either ignore it if it's too big, or I think the prompt that was leaked from Claude Code is like, only read this specific Claude MD if it has to do with the question. The problem is that that's very subjective, right? So you want to treat this almost like as a map. They call it progressive disclosure, right? So like, hey, here's where all our tests are. Hey, we do this weird thing with this weird version of TypeScript because we have to because of our environment. Stuff like that. You don't want to overwhelm it. It's just more of a map to find stuff, etc. And it can dig deeper if you tell like, hey, all of our docs are here. If you need to find the specific one for the setup, go look here. Number two, honestly, I kind of had a hard time understanding this, but from what I understand from their article is that, Git is and this is common sense, I don't know why they include it, but, Git itself now has become documentation. Now it always was, but it's worth mentioning something like lazy Git, something like, I don't know any other tools, honestly. The point is that Git is very important now more than ever. You don't want to have huge commits. I've effectively banned huge commits at my organization because, again, you can go very fast. I don't care how fast you go if it's pure slop, small commits always. And I am able to easily, quickly, reflog, git blame, etc. with lazy Git because I can just say, hey, here's these 10 commits for these days. Okay, I see here where they did. Okay, boom, go there, fix that issue. Versus if you let the team go, you have a huge amount of code and you have huge commits. It's a pain in the ass to debug. It's a pain in the ass to roll back. So this is what they were calling a self-healing loop. And I think, again, a lot of these principles people are getting towards or coming towards without interacting. And I think it's interesting that everyone has, for the most part, arrived at the same conclusions. But it's pretty much just saying like, hey, you have something like a quality gate that's being enforced at the code level. After you commit, run the linters. And this is kind of what Plankton from Fazio, shout out to Freaky Friday, Fazio. The Plankton project is pretty much saying like, hey, whenever Claude Code does a diff, run the linters, hide the output, just tell me if it failed or not. And if it failed, tell me why it failed. That's what Plankton is doing. They also do a lot of work with the work trees, and this also becomes important because I tend to spin up a lot of work trees for research. So I'll spin up 5 work trees, fire off 5 agents in the background. I don't even have to look at it. I don't have to think about it. Maybe it's complete as, maybe it's useful, but for the most part, I just fire these off for research. And again, that's stuff that would have taken me hours before. Now I can do it within 30 minutes. I won't go through the rest because I think it's kind of redundant, but you get the gist. This is worth mentioning. So, how do I say this? This always mattered, but it matters now again 10 times more. Your code base has to be organized. Your repo has to be organized. If you just have a bunch of random directories with no structure, no modules, the code agents are going to look at that as a pattern, and they're going to say, oh, Tuna didn't make any directory specifically for the database. We're just going to put it in the root, right? And then that'll keep building on top of each other. So it's very important that your hygiene of your repo, again, it always was supposed to be this way, but it's even more important now because it'll look at it as a pattern. And you want to make the code base as easy to read as possible, not only for humans, of course, but for the agents, because it becomes a prompt in itself. And if your documentation is outdated and 5 Claude Code agents have read it and they are working under that unorganized or wrong information, right, you're going to have a really bad time. It's worth making sure you iron this stuff out ahead of time to make the code agent's job a lot easier. Okay, and you can see here it finished, right? So it did 5 new files. 4 files were modified. It input all my tasks. They have a rollback, right? So if I say, hey, it's just complete slop, I can just straight up roll back to the baseline because it committed nice and cleanly like I need it to, right? I'm not just gonna guess what is the action it took. I can just go back and lazy Git and look at the commits easily. Key features that I added, and also just outline here what I had. So now I'll say something like open APR. And then it'll be a PR that's open on the project, and it will have it'll have an automatically be review with CodeRabbit, and you'll see here an example of what I mean. So I'll wait for it to come through. but you can see here, let's see. So the pull request was opened, and then CodeRabbit went through and just gave you a walkthrough. In this case, it was a pretty simple one, so it didn't have anything too crazy to add. Just kind of gave me a walkthrough of the changes. Let's see something bigger. Okay, yeah, so you can see here, right? It starts to outline the issues. It'll tell like, hey, this is probably a minor issue, but it's worth cleaning up. Stuff like this is a second set of eyes. Again, nothing's going to replace your own common sense, but due to the volume of the code that can be generated now, this is much more important than ever. I think that's pretty much it. Again, you can, sorry about that. You can go pretty deep in this, but all this is built out this basic workflow, researching, planning, execution, and code review. That is the foundation of agentic engineering from first principles as an empath. Thank you.